Hello guys, how are you doing? Let me trust you're doing good wherever you are. Today I'm going to teach you how to test for a short in the motherboard. It doesn't matter which model of the motherboard you're dealing with, but whatever I'm going to discuss today, it will cut across all the motherboards which you're dealing with. So laptop motherboard, it has several lines, that is not even several. It has the main power line, that is the main power line. It also have what's called the secondary power line, and it has the tertiary power lanes. All these power lanes, they are not supposed to connect to ground in any way. So before you start testing, first of all you need to understand which are the main power lanes, or which are the components which are in the main power lane. Then from there you will be able, and it will be easier for you to test. So here with me I have several motherboards which you are going to test for whatever you are going to test. So I have the 1030 G4 motherboard, I have 1040 G7 motherboard or 1030 G7 motherboard, they are also the same. I have 835 motherboard. So this one was supposed to be 840, but you can see this having an AMD processor, that is why it qualifies to be 835 motherboard. And then finally I have another motherboard for 840 G5. So we are going to use these motherboards to discuss whatever we are going to discuss. So, as I always say, make sure digital multimeter be your best friend, because always it is your best friend. It will never trick you. It will show you the actual measurements, whether it is a short, whether it is a Holmes mode, whether it is resistance, whether it is voltage, whatever you are measuring. Your digital multimeter can never show you wrong readings. That's why I always say make it to be your best friend. So here with me I have a digital multimeter because we want to test for the short to the ground. That's why we are selecting the continuity mode. You can see my pointer is pointing to the selection of a continuity, pipping mode, and capacitance and the diode mode. Then from there you can see my screen is showing mega ohms. So meaning we are in ohms mode. We want the pipping mode. Even the homes mode can give us the readings, but I like us to use the pipping mode because I know most of our digital multimeters have those readings. So we'll have to select the pipping mode. Now you can see we have the bell icon there. That tells you we are in the pipping mode, and we also have the homes mode simple there to show us we can also have the readings of resistance. So we said the first thing you need to understand which are the main power lanes. The main power lane is an input, positive input or of any circuit. For example, here I have a circuit here which is represented by capacitors, PD controller which is the monolithic driver, and then we have stacked inductor. Any stacked inductor represents a circuit. So we'll have stacked inductor, monolithic driver of that line, and the capacitors to filter and to ensure the steady power through that line. Same case applies here. We have monolithic driver, stacked inductor, capacitors for that line. Here we have a stacked inductor, monolithic driver, and then we have the BD controller. It has so many names. It could be BD controller, monolithic driver, and then we have the capacitors for the input power line. And then same case applies here. So all these inductors represent a circuit by themselves. So when you see an inductor, it must have an IC which produces a voltage which can be regulated by that inductor. You can see each and every inductor has an IC which produces a voltage which can be regulated by that. And also it must have some capacitors around there for the filtering process and the steady supply of power. Capacitors are in different types. We could have ceramic capacitors like this one. See that these are called ceramic capacitors. You could have tantalum capacitor like this one. And then with older models of the laptop, like I believe I have one here. With the older models like this one, we will have what's called the chemical capacitors. Can you see this one? So these ones are called the chemical capacitors, which also work best like the rest. I can see some people when you don't get this capacitor, you want to replace this, and then you find out that you don't have any. You could replace with this one. You can replace with this tantalum because they have the same capacitance value. They are strong enough to withstand the voltage which is going through that line. So I said any positive input of a power supply is a power line. The only thing you don't know whether it is the main power line or it is a secondary power line. The main power line is the input of this. So the input of this before the step down, because these BD controllers are the one which step down a voltage. So meaning they step down from the main power line to the secondary power line. So these ones are the secondary power line. The other one is the main power line. So how do you test? The only way to test, I said, you make sure your meter is in continuity mode, and then one of your props to be to the ground. So any screw hole is the ground, or even these metallic pods are the ground. So make sure one probe is in the ground. We say the screw holes are the ground, and then from there you need to determine at the input circuit which line, which particular side is the ground. So this side is the ground. That is why you can see there's low resistance. So ground against this side, you can see it is reading 0 ohms and it is peeping. You can see this LED here. There's an LED there which is showing red and it's also peeping. Yeah? So meaning this side is the ground and then the other side should not peep. Why? Because this side is not connecting to the ground. So that tells you this line is good. Not only that line, it tells you that main power line is good because that is the line which is connecting to the main power line. So as you can see, it is showing OL, that is open line. It is open. It is not connected to each other. It is not connected to the ground. That's why it is showing OL. In the case I had some low readings or low values, it will mean I have a short. The ground is shorting to the ground. Now, both sides will be reading low values. However, the side which is showing the ground, it will have lower value than the side which should be positive. If this side was reading 00 ohms, or let's say it is reading 1.5, can you see? It is showing 0.9 or 1.0. The other side, it will peep, but it will show like 3 point something or 4.2, something like that. But it will not be lower than the actual ground. All the main power lines should not read the same. Can you see? If this one, see this side is the ground, the other side should not beep. But now, can you let us say this side is reading 1.5, so meaning that's the ground. What about the other side? The other side is not reading anything, meaning that one side is good. Now, apart from that, so that tells you the input is good. What about the output? The output also have the same thing because these ones are not supposed to connect to the ground, meaning they will not beep to the ground, not unless it is applying power to the CPU, not unless it is applying power to the CPU, because these inductors, I believe they're supplying power to the CPU, so it will beep. However, the readings will not be almost 1.5. You see the ground there is showing 1.5. For these inductors, I'll expect them to be beeping because it is applying power to the CPU, but it will have some values. Can you see this one is beeping at 6.7, meaning it is good because against the ground it is 1.5, but this one is showing 7 point something, meaning that 6.4. That line is good and the CPU is good. If it was showing value which is almost 1.5, it will mean the CPU is shorted to the ground, which is very bad news. This one 7.5 good, 7.5 good. Having said that, I said any other power supply is not that doesn't peep. For example, this one. I believe this one is not taking any power to the CPU, not unless the sign which is going is bad. You can see this one is reading over 500 ohms, that is 595 ohms, which is good line. What about this one? 89 ohms, which is also good. What about this side? OL, which is good. Then let us see this other side. What about this smaller one? Still, you can see this one is having 113 ohms, which is good because it is not taking power the CPU. Then this one, it is also good. Having said that, let us test this other motherboard. Ground. Now, and us to check the main power lane first. The main power lane, you can use this in this input circuit for the CPU. So this side is the ground. You can see this showing 3.5. What about the other side? showing oil, meaning it is good. The main power line is good. Sometimes we use the inductor which release power to the main power line. This one, this current sense resistor. You can see the current sense resistor is good. Let us also try other inductors. This one is good. This one, good. This one is showing 4.5. What was the ground showing? The ground was 2.2. So 4.7 is good. Why? Because you can see the output is going to the CPU, meaning that 4.7 is the resistance from the CPU. 4.7 minus 2.2, we will find like 2.5, meaning that's the resistance value for the CPU. This one this is now bad. This is bad news. Can you see this one is showing 2.4? And then against the ground was also something like 2.4. Now against the ground was 1.2, which is also good. Which is also good, not bad. This one 11 ohms, which is good. This one 81 ohms, good. This one 70 ohms. OL, 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 which are good. So that is how you test. Let us see this one for the AMD. First, can we start from this AMD CPU? We see whether it is good. We say we test the positive 30 ohms, which is good. And then from there, all these other, I believe these ones are joined, meaning even here should be 30 ohms because they are supplying the same line. That one, 30 ohms, which is good. Here, I don't expect to have any peeping, not unless it is that line is shorted here. It's good. This one, good. This one, I believe here also is applying to the CPU. 50 ohms, and it is peeping, which is good. 22 ohms, good. 50 ohms, good. Now tell me, why am I having 30 ohms here, 22 ohms here, and 50 ohms here, and all of them are going inside the CPU? Yes, I know you're wondering why. Why do I have 50 ohms, 22 ohms, and 30 ohms, and all of them are going into the one component? So let me use this Intel to explain to that. As you can see, with this CPU, I have two main chipsets inside. I have the CPU itself, this bigger one, and then I also have the PCH here. So meaning this power supply is coming into the CPU. Some are coming inside to this CPU. Some are going into the PCH. And inside the PCH, we also have the NOT bridge and the SOD bridge, meaning we need power also going to the NOT bridge and another power going to the SOD bridge. Here, at the same inside here, this PCH. Same case applies here. We could also have other departments inside here. Let me use an analogy of an institution. So within this processing unit, these are processing unit. That's what you call the CPU, Central Processing Unit. So we have several units inside. And those units which are inside, they need different types of power, different voltages, different current. So that is why we have more than one power supply to this unit, of the processing. Same case if the power coming to the PCH, we will have power needed by the north bridge, and we also have power needed by the south bridge. Let me hope it is sinking into your brain. Same case applies here. We'll also that because the CPU, AMD CPU, meaning there are several units inside which need different kind of voltages. That's why we'll have a power coming from this line. We'll have power coming from this line. We'll have power coming from this line. That is why when we have schematic or when you check the voltages going for the CPU, we call them the VCC cores. So the VCC core of a CPU, you will have like 0.8 voltage, 0.9 voltage, 1.1 voltage, 1.0 voltage, and all those voltages are going to the one unit, that is the CPU. So the reason I believe I have explained why we need several power supply towards the CPU, because inside there we have several units which need different kind of powers. So same case applies here. You can see we have the CPU power, CPU power supply, CPU power supply, all of them are the CPU because the entire unit is the CPU, right? Let us test this motherboard where it is shorted to the ground. Continuity, make sure the meter is in piping mode, continuity, ground. Then this one, 20 ohms, good. This one, I am testing against the inductor, 14 ohms, good. This one, 14 ohms, good. And what is the ground? Ground is 1.5. So any value less than 1.5, here 14, good. Here, I believe this one is also good, 45 ohms, good. What about here? This one now is bad. You see, the output for this one and it's going to CPU is reading 1.3. And we said against the ground is 1.5 or 1.3. So meaning this line is the one which is shorting to the ground. And this line is going to the PCH. Maybe South Bridge or North Bridge. I don't know which exactly line is that. So if I can remember very clearly, this motherboard dies because somebody plugged in something onto the dock station. You see, there was a burned something here, and this port was burned. So I believe this line got burned because of whatever happens here, and this thing is being controlled by the Saudi bridge which is inside here. So that is how this motherboard dies. So let us continue testing. So ground against this line. This line also good. What about this line? This line also good. What about this one which generates the main power line? Is also good. Do you understand now? Now let us see the main power line. The main power line, we said all the input, the positive input of any circuit, like here. So this is the input because the power comes in here, then it is stepped down and then released through there. So the input to the ground, believe you can see, or can I bring it closer so that you can see? So one probe to the ground, and then we see. Let me put there. Can you see the readings? I don't know. Can I make it visible enough? You put it there. Now pay attention to the reading. So we say all the inputs are here. So here against the ground, OL, meaning it is not connected to the ground. Then we have also here against the ground, which is also good. Against the ground, which is also good. And then the positive line against the ground, which is also good. Same case applies here. So the IC was here, was supposed to be here. And then the positive side is here, which is also good. What about here? So the input is this particular point because the input for this circuit, so the input against the ground, which is also good. Here IC is here, so the input is this side, which is also good. You see now how you can test the main power line against the ground. That is the best and the shortest way for you to determine whether the motherboard is shorted. Once you know it is shorted, for example, let's assume we measured this particular point and found that it is beeping and it is reading 0 ohms. For example, this line, let's assume here we had 0 ohms or it was beeping against the ground. So here it could mean several things are the one shorted. It could be this IC is shorting this particular side to the ground, so the output of this IC is shorting to the ground, or these other components along this line are the one which are shorting this line to the ground. If this IC was the one having an issue, it could be the problem is about the output of this or the input. But most of the time, BD controllers got an issue to do with the input. So we could head the main power shorting to the ground because this chip short the positive to the ground of this IC of the input. So you will find all this input power, all the main power line here, 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 all these inputs, it could have shorted to the ground, and we could see the readings reading 0 ohms. And so it was now up to us to find out which particular component is shooting that line to the ground. The main power line, you can see the big truck. So this big truck is the one which is carrying the voltage in the main power line. And then these BD controllers are the one which step down the line coming from the main power line to the several secondary lanes. That's why we have the secondary line here, secondary line here. All these inductors represent the secondary line except this one. because this one, it will now take the voltage from from this port, that is 19, or from this port which is 19. It will receive that 19 through this MOSFET, and then this IC will step down the 19 to the standard main power line voltage, which is in the battery, which could be 11 or 12 or 13 sometime. And then that voltage is regulated by this big inductor, sent through this I side MOSFET to this current source resistor, and then to the main power line. So guys, let me believe at least I shared a good content which will enable you to diagnose and find out an issue with the main power line in your laptop. So when you have a problem with your motherboard, if it is the main power line shorted, at least you can figure out. If it is the secondary line shorted, at least you can also figure out, because you have to test one by one, each line by each line, and you need to be composed, because sometimes you are tensed, and then you are not able, even you don't even comprehend what you are testing. I know sometimes you might be having fear measure, but I can advise you, if you don't have courage enough to deal with the motherboard, please don't, because you might end up doing what? You might end up causing more problems or more damages into your motherboard than avoiding the solutions. So you need to be careful enough while working with these things. Sometimes if you're not careful, you find that instead of you now diagnosing, or instead of you finding a solution, you're creating more problems into your laptops, and it's a very bad. It will not be good, and I am sure it will demoralize you. Until next time, you will not want even to try. Yes. So before you start again doing this, make sure you do more research. Yes, make sure you do more research. You find a way to instill confidence in yourself. Yes, because without that confidence and without the knowledge, you will not. I don't want to say you will not succeed, because sometimes somebody with fear, with no confidence, by luck, you find yourself fixing a laptop motherboard. So anyway, guys, I will show the very best in your channel in learning how to fix these motherboards, and I'm very happy if I find a comment saying, "Oh, I was able to test for a short, I was able to fix a shorted motherboard because of you." I'll feel good though. Anyway, thank you so much, guys, for watching this video. In case you haven't subscribed, I am still requesting you. I'm still asking you guys, please subscribe, share with your friends, give us some comments. And in case you're also interested in learning about laptop repairs, we do teach both online and offline. You're welcome also to join us. Reach me out in case you have any issue. You have my contact details, that is the WhatsApp number in my profile. You can just reach me out so that we can discuss the way forward. Thank you so much, guys. Do not forget to subscribe, and see you in the next video. Goodbye.